And I would be remiss not to acknowledge my board chair, Charles Wilkinson, here in the corner, who makes all of this possible. And then also, when I talked about all the folks who are interested in this, I neglected to mention our two Boulder County commissioners who are here. Elise Jones is here and Deb Gardner, I believe, as well. And it's terrific. All right, so Sean actually asked me to talk about drought and climate change. And this is specifically on the adaptation side, because we've heard a lot about mitigation. And, you know, it used to be that adaptation was the fourth stepchild, right? That we were giving up if we had somehow decided we needed to adapt. And now we have a huge amount of baked-in warming, and guess what? We are going to get to adapt to it. So I want to talk about these 5 or 6 points here quickly. Just the connection between drought and climate change and water, because climate change really is water change. And Admiral Titley, who was in charge of the Navy's adaptation program, said it best to me in a 10-second elevator speech. He said, Brad, climate change is all about water. It's about liquid water, it's about frozen water, it's about seawater, and it's about fresh water. That's the best way to describe climate change that I know about. I want to talk about fires, just because they've been so prominent here in this state recently. I want to talk about drought and high temps and the connection. A little bit about bark beetles, water supply, including especially the Colorado River, and then finally get to what the President mentioned in his speech but has yet to fill out, drought resilience, partnership, and adaptation. And I want to note to many of the scientists in this audience that I think science has sort of gotten itself wrapped around the axle in terms of trying to attribute events that we are seeing to climate change. And I say this because we live in a world right now of global change, and there are an incredible number of additional stressors out there. In the water sector, for example, our impacts to that sector are enormous already, and climate change is a stress enhancer. And this is true of almost about anything I'm going to talk about today. So, first point, climate change is water change. You know, 1,000 cubic kilometers of water evaporate every day in the world. And within that is an enormous amount of energy. As the atmosphere warms, it's going to hold more moisture, significantly more moisture. And if you heat up the Earth, as we're doing, and especially if you heat it unevenly, in our case we're heating the poles, the North Pole, about twice as fast as the equator, you're going to end up with changes in the water cycle. You have to. More evap, more precipitation, more moisture. You're going to see big changes in weather patterns. The standard rule is wet gets wetter and dry gets drier, more intense floods and droughts. And most of these changes we're seeing planet-wide already. And I have said, and many others have said, that many of the most important impacts that we're going to see out of climate change are not due to rising temperatures, but actually these big changes in the water cycle. And arguably, the greatest impact that climate change causes, sea level rise, is in fact a water cycle change, if you think about it. It's a water cycle change on the order of 10 and 20,000 years involving these big ice sheets. It's not normally how we think about the water cycle, but it in fact is also a water cycle change. So what about fires? I mean, here's a list of 5 that we've seen in just the Front Range in recent years. And every year, we seem to see yet a bigger, more destructive fire. I'll note that this year's Black Forest fire started on the date at which Denver reached the earliest 100-degree temperature in its recorded history. And that connection between high temperatures and fires has been well known in this graph here from a paper that's been cited over 1,000 times now in Science magazine in 2006, demonstrates this connection in the black line between high temps and wildfire frequency in red bars starting in about 1985. This image here I actually took from Walkway last year when the Flagstaff fire started and threatened my house. And I know, Tisha, you've actually been impacted by one of these fires as well. We're going to see more of these. All right, so what about drought and high temperatures? This actually comes out of Texas. It's not too hard to find 2011 there. And the interesting thing here is you can do imagery from airplanes or satellites, and if you have a wet field full of soil moisture and a dry field right next to them, the land surface temperature can vary by up to 50 degrees Fahrenheit. And so high temperatures and drought, no matter what the cause, are intrinsically related. And we're going to see more of these kinds of outlier years. And I know, Sean, you were just down in the southeast portion of the state where they have stage 4 drought there. It's Dust Bowl conditions. Perhaps slight improvement recently, but unbelievably dry. Or what about these bark beetles? That's 50 million acres in red there in British Columbia. We think we have it bad at our 3 or 4 million acres in red down there in Colorado. But we also have spruce and pinyon beetles out there. And these bark beetle outbreaks have been linked to higher temperatures and drought for sure, both. And this is one of these complicated global change situations where it's part natural cycle. But this new warmth allows 2 life cycles per year, and beetles now can move into higher elevations where previously they got frozen out by really cold winters. We're not exactly sure what happens and what regenerates in these stands, but as it gets warmer, I'm going to bet that interesting things take place that we cannot anticipate. And what about this? So these are the 2 largest reservoirs in the United States. Lake Mead, which was built in 1935, and Lake Powell, where the gates closed in 1963. And on the far left, you can see the contents, so the combined contents of both. On the far left, you can see where only Lake Mead existed up to 1963. And then in green, you can see the initial filling of Lake Powell. And from about 1980 to 1990, we entered an era that maybe we can call normal, although in the future, I think it's going to be anything but normal. And then in the year 2000, you can see this 14 years of unprecedented drought. And I recently heard that our tree ring scientists are telling us that this drought may in fact be quite unusual even in the 1,200-year tree ring record that we have. So if you look at the far right side of that red line, right where the blue and sort of gray line meet, there's a little red point where that graph ends, and that's a month from now, projection for a month from now. And follow that horizontal line way back over. So at the end of this water year, at the end of September, these 2 reservoirs are going to reach a level not seen since 1968, when Powell was initially filled. And because of this, we think reclamation, which controls the river, is going to declare a shortage sometime in the next year or 2. This will be the first ever shortage in the Colorado River. And mind you, even though we live outside the basin, half the water in those pictures there comes out of the Colorado River in many, many years. So we're highly dependent upon this system. And reclamation through an interesting law, which in fact is the only law on the books which mandates adaptation actions by the federal government. It's called the Secure Water Act. It was generated at Senator Bingham's Energy and Natural Resources, the committee in which my brother serves. And in fact, it was written by Mike Connor, who just served as Reclamation. Commissioner of Reclamation is now going to be the Deputy Secretary of DOI. That act actually mandates reclamation to do projections of future supply and demand imbalances. And their report, released in December, says that by 2060, under median climate change conditions, which I think is deceptive, but median climate change conditions, there'll be a 20% supply and demand imbalance. And for those of you who are water policy junkies, that's 3 million acre-feet. It's water for 6 million homes, and perhaps as many as 20 or 25 million people, to give you the size of that imbalance at 2060. Part climate change, part overuse for sure. So what about an adaptation and the President's Drought Resilience Partnership? Of course, we're going to get to go do both here. We're going to get to mitigate and adapt. You know, we already have significant baked-in warming, and now we're at 400 parts per million and no signs of slowing down with regard to CO2 concentrations. And there are obviously lots of other stressors involved. We're going to get to adapt to a global changed world. The President's Drought Resilient Partnership caught my eye because he announced it and is yet to supply details. But let me give you a couple ideas for maybe what should be in it. So when you do assessments on climate change, and I've been part of several of them, including the 2009 National Assessment, the one thing that jumps out at you is water is connected to everything. And if you're going to do a partnership like this, it needs to work on water supply, it needs to work on agriculture, and especially energy. This connection between water and energy is fascinating and it's becoming more and more apparent every day. where in some cases we're literally shutting down power plants because of too warm temperatures for cooling water. An information clearinghouse, the federal government could clearly do a better job. There's something like 20 different agencies that have an interest in water, and to be able to do that better would be quite useful. We do right now as a nation an incredible poor job of monitoring soil moisture. And this isn't something that just earthworms and gardeners and farmers should be concerned about. It's something that all should be concerned about, because that soil moisture is what keeps the land surface cool. And it disappears when you didn't know about it. And then finally, let me suggest that we need to enhance what's called NIDIS, the National Integrated Drought Information System. And its headquarters is actually just down the road here at the NOAA building. And it's a Western Governors Association effort initially, and NOAA picked it up and has run with it. And it's the one dog we have in the hunt in the national nature of dealing with drought. So I'm going to end there, and I think we're going to do some questions with Sean. I want to thank you all again for turning out this morning. Our plan here is to end at 10:20, or 10:30, excuse me. And you've all been a terrific audience, and I think that Colorado's finest are not even going to be needed. So thank you so much.